Hello guys, welcome to PLC Goods video tutorial. In this video we are going to learn the basic concepts of a human-machine interface or HMI. An HMI is a user interface tool that connects an operator to a controller of an industrial system. After a short introduction, I will show you how Factory Talk View can connect to a controller to visualize an industrial process. Also, I will use the software to design an HMI screen. I will use my computer as an HMI station using Factory Talk View. Then we will see how an HMI device can be programmed and connected to a PLC. I program my HMI panel using EasyBuilder 8000 software. There are a lot of HMI devices made by different vendors, but we can use at least one software to design suitable screens for any brand of HMI devices. So if you learn to program any of them, you will be able to work with other brands easily. Then I will design a suitable HMI screen to monitor and control a process in Factory IO. Let's see the industrial automation pyramid image again. The equipment at the lowest level can be controlled by a PLC. Besides the PLCs, we can use HMI devices to control these field devices as well. An HMI device can translate complex information on a PLC memory into usable and manually controllable information. I can use my computer as an HMI station. In this video, first I will use Factory Talk View to design a simple HMI screen inside my computer. Then I will program my HMI panel using a USB cable and connect it to my PLC via a serial cable. This is my HMI brand that I can program it with EasyBuilder 8000. First, let's learn how we can use Factory Talk View to design an HMI screen on our computer. Here is a simple program that I transferred it to my PLC. This digital input enables this timer, and this one turns on this digital output. An HMI cannot alter an existing voltage on input terminals of a PLC, but it can communicate with a PLC. I will use this internal tag on my HMI screen to turn an output on. We learned how to design an HMI screen by Factory Talk View and to connect it to this virtual controller. Now I want to connect it to my real PLC to monitor and control a simple program. Let's open Factory Talk View software to create a new project. Usually, each HMI designing software has a screen as its main or a starter screen to start editing an HMI design. Here are some objects which can be used to design a suitable screen. Let me add this momentary push button object. We can change the properties of each object like its size, color, and so on. A push button has 3 states. Now I am changing its color and text. There are several properties that can be changed, but the main property for each object is its connection settings. Here I can connect the momentary push button to a tag of a PLC memory. First, I need to determine connection settings. Usually, if both HMI and controller devices belong to the same manufacturer, then they can be connected together easily. Let's create a new connection. Now on the right side, I can see all connected controllers like RSLogix. Here I can select my desired controller easily and connect it to Factory Talk View. Now let me connect the momentary push button to a tag of my PLC program. First, I click on Refresh All icon. Now I can connect the momentary push button to a Boolean tag of my program. Here are the real input-output addresses of my hardware. Let me select From HMI tag. In my program, I use this tag to turn on or off the first digital output. Now I want to add two green and red lights to my HMI screen to display a state of the first digital output. Let me change the size of the green light. Now let me select the visibility option under the animation menu. I want to depend on the visibility of lights to the first digital output. When the first digital output is off, the green light should be visible. In other words, when the first digital output is on, the green light should be invisible. Similarly, when the first digital output is on, the red light should be visible. Otherwise, it needs to become invisible. Until now, I showed you how to use an HMI screen to change or monitor a Boolean tag or address. An integer number is the most common numeric data type. So let me insert a numeric display into my screen. Let's use default settings for the numeric display and connect it to the accumulator value of a timer inside the PLC program to display a time in milliseconds. Also, I can change numeric data from the HMI screen. I need to use a numeric input enable object. Let me connect it to a preset value of a timer to change it in the program. We learned how numeric data can be changed by an HMI screen or monitor its value. Let's test the design screen. Let's have a better view of my PLC, its program, and the HMI screen. First, let's activate the timer instruction. The current time can be monitored on the HMI screen. Now let's disable the timer and press this push button to turn on the first digital output. Also, I can use this momentary push button inside the HMI screen to turn on the digital output. Finally, if I click here, a window will appear to enter a number which will be stored as the preset value of the timer. Okay, this is a simple HMI screen designed by Factory Top View. I used my computer as an HMI station to monitor and control a PLC program. Also, I have an HMI device utilized for industrial processes. This is its model, and I can use EasyBuilder 8000 software to program it. Let's see how a screen can be designed for this HMI and how it can be connected to a PLC. First, let's launch EasyBuilder Project Manager. My HMI belongs to this group, MT6000 8000 series, and it's connected to my computer using a USB cable. It also supports a serial port. I use that to make a connection between the HMI and the PLC. First, let's reboot the HMI to ensure the connection is established between my computer and HMI. Here are some options inside the current window, like download or upload a project. First, let's click here to launch EasyBuilder 8000 to design a screen. Let's create a new project. Here, let me select the HMI model and use a template for the new project. The main part of designing an HMI screen is its connection settings. By default, the HMI is connected to itself. In other words, it can use its own memory. Now let me create a connection between the HMI and PLC. Here is a list of different types of PLCs from many manufacturers. Based on my PLC station, let me open the Rockwell Automation Incorporated submenu and select Compact Logix Free Tag Names option. Here I determine the connection type between PLC and HMI. I am using a serial cable, so let's select the RS232 item. Note that my PLC has a serial port. I can modify the other connection settings. Let me use its default settings. Note that some PLC types, like my MicroLogix 1500 PLC, use predefined addresses. For instance, this is the first Boolean memory address of my MicroLogix 1500 PLC, so I can easily use this address on the HMI screen too. On the other side, we define our tags for some PLCs, like the ControlLogix 5562 controller. The defined tags don't have any specific format, so I need to import them into the HMI. I use these tags in RSLogix 5000. Now let me define another tag. The state of this tag is the same of this digital output, so I can use this tag inside my HMI screen to display the state of the digital output. Now let me download the program to my PLC. Now I want to transfer the defined tags, like these tags inside the program tags table, to my HMI screen. First, I right-click on this folder and select Export Tags. Also, I can do the current exporting process for the controller tags table. Here, I can define a name and where the tags should be exported. Let me use the Logic Comments menu and select the All item to select all tags, then click on Export. Now let's import the tags to EasyBuilder 8000. This message says tags were imported successfully. Here are many objects that can be used to design an HMI screen. Let me insert a toggle switch object. First, let me connect it to a tag of my PLC program. Now let me select a shape for that. Now I want to add this object to my HMI screen to display the state of the first digital output. So let me connect it to its related tag. Now let me add a numeric object and connect it to the preset value of the timer in my PLC program. Similarly, let's use another numeric object to display the current time in my PLC program. Now let me compile the designed screen to ensure there isn't any error. Now let me download the screen to my HMI using its USB cable port. Now let's have a better view of the PLC program in my HMI. I can turn on or off the digital output from my HMI screen. Also, if I activate the timer, I can see its accumulator value on the HMI. Now let's change the preset value of the timer using this window. I hope you learned basic concepts about HMIs during this video. Note that HMIs are widely used in various industries and they have more capabilities rather than the two mentioned projects here. Now we are going to do a more complex project. Here are two systems inside Factory IO. The first one picks up boxes from the belt conveyor and it places them on pallets. Then this conveyor moves them to the stacker crane to place them on the racks. The second system is a water tank which works independently. We worked with these two systems during the previous videos. I wrote a PLC program to control these two systems. Let me change my controller mode to run mode to test the program. Also, I have designed two screens on my HMI to monitor and control the systems. This arm picks up boxes and places them on the pallets. Note that there are two sensors that are used to detect boxes and pallets. Here is also another one. When a prepared box reaches to the end of the roller conveyor, the stacker crane starts its work. We wrote an SFC program in 9 steps for the crane system in lesson number 30. In this video, I used that with a little modification. Obviously, my designed HMI screen displays the current step of the stacker crane. Also on the right side, we can view which positions are empty or filled. Right now, the second position is empty, so the next box will be transferred there. When there is a prepared box for the stacker crane, this arm stops. and the ruler conveyor doesn't send another box. A simple operator cannot work with the PLC program, but he can work with this HMI screen. A simple operator can easily detect the current step of the stacker crane and can detect the empty or filled positions using the HMI screen. Suitable text can be used on HMI screens to display necessary information, messages, or alerts. The program we developed in lesson number 30 could detect an empty position automatically. The controller displays a detected empty position here and on the HMI screen as well. I can use these two push buttons to pause or resume the crane process. Let me press the red push button. Obviously, the controller has stopped the crane system at its 8th step and this arm and the ruler conveyor, because there is a box that should be picked up by the crane. Let me resume the process by pressing the green push button. Also, I can pause and resume the process using these two buttons on the HMI screen. Now the controller has stopped the crane at its first step. Let me resume the process again. I can use my real hardware to control the design process inside Factory IO. I use the first and second digital input addresses to pause and resume the process. Now the process has stopped at the 4th step. Let me resume that. So I can pause or resume the process using the digital inputs, the virtual push buttons inside Factory IO, or the buttons on the HMI screen. Now let's test the water tank system. On the HMI, let's select the main screen and next the tank level control screen. Here I can use a slider to determine my desired water level. After that, my PLC program compares the desired level with the current level. Then it opens the filling or discharging valve. I explained the water tank system during lesson numbers 22 and 26. Now the desired level is greater than the current level, so the PLC opens the filling valve. Let's wait until the water level reaches the desired level. The water level has reached the desired level. Let me decrease the desired level. Now the controller opens the discharging valve. The first system is filling empty racks with boxes, so PLC is controlling two systems simultaneously and HMI has two screens as well. An operator can navigate between screens to monitor and control both systems. A box is moving to a 7th position and we can notice this point using the HMI screen. Let me pause the process by touching the related button on the HMI screen. Let me remind you some points about the program. Inside RSLogix 5000, under the main task, I divided my program into 3 parts. The first program folder is the racks folder. Its main routine calls this SFC program to control the crane system. At the second run, a green push button inside Factory IO, a button on the HMI screen, and the first real digital input are used to execute the SFC program. Similarly, the third run can pause the SFC program. The SFC program consists of 9 steps which were explained during lesson number 30. Now it's paused. Let me resume this SFC program by touching the related button on the HMI screen. The next program folder, Pick Place, prepares boxes and sends them to the stacker crane. Its main routine calls another SFC program. I can use the HMI screen or RSLogix 5000 to detect the current step of the program execution. Naturally, operators prefer to work with HMIs because HMIs can translate complex process variables on a PLC memory into a controllable information on an HMI screen. The next program folder, Tank, includes the program which controls the water tank system. I can use this slider to change the desired level. Then the program compares its value with the current level. Now it sends 10 volts to the filling valve to open it completely. Note that here you can determine which program folder must be executed first. Now I cannot change the order of the execution. I should exit from the online mode. Note that I can remove each program folder from the right list. For instance, now the tank folder belongs to the unscheduled programs folder. So if I download my project, my PLC won't execute my program inside the tank folder. Let's add it to the main task folder. Notice each program folder has its specified program tags table, and all of them can use the defined tags inside the controller tags table. My PLC is filling empty racks. The stacker crane and the water tank system were explained before. Now let me pause the controller and remind you some points about this arm and the HMI screens. This arm has 3 actuators and 3 sensors. The first actuator moves the arm horizontally. Its related sensor is on during a horizontal movement. Similarly, this actuator moves the arm vertically and its related sensor is on during this direction of movement. The third actuator can be used to grab boxes. Its related sensor is on when a box is detected under the arm. Another point is about this type of loading conveyor. It works like the ruler conveyor. It can be added from the right list as well. Let me explain the HMI screens using EasyBuilder 8000. The first ability of each HMI is defining several screens. I use 3 screens and I navigated between them. Naturally, I can have more than 3 screens. On each screen, we can use images or suitable text. Also, we can use and change numeric values, which were explained in the previous video. Here is a slider to change numeric data. I can add it from here. Then I should connect it to the numeric memory on the PLC memory, which stores the desired level. On the left side, I used a bar graph to display the water level. In its properties windows, I defined its minimum and maximum values. Then I connected that to the PLC memory, which represents the current level. Inside this screen, I added these bit lamp objects from here. Each bit lamp object is connected to a bit of a PLC memory, which represents whether the related step is activated or not. Similarly, I used 54-bit lamps to display the state of the racks. Note that toggle switches can be used like real push buttons on the HMI screens. Another point is using function keys to navigate between the screens. Here I can select any screen. Note that HMI devices have more abilities to store or display data, define alarms or passwords on HMI screens, and so on. Conclusion. We learned basic concepts about HMI devices using Factory TalkView and EasyBuilder 8000. Also, I showed you how real equipment like push buttons and signal lamps or virtual equipment inside Factory IO can be connected to a controller. I hope you guys enjoyed watching these tutorial lessons as much as I enjoyed preparing them. Take care.